Hello everybody, this is Todd Frazee and this is the tutorial for the 7311 cam or pivot arm cam tutorial. So you should have already modeled this part shown on this drawing, and we are going to reference the drawing because of the tolerances, our model, and you also will need to reference the job traveler. Now this is printed in, is not available on Canvas, but it's printed in the shop. And just to review how we fill this out, here we have a programming operation here. So this is when you go back to the school, these programming operations for each step would only be done the first time you run the part. After that, that traveler or routing would be modified to remove the programming operation. So in that process, you usually have someone on an administrative level that is doing those changes, but you need to put the program number, your work offset used, and the tool numbers you used, not necessarily the sizes. That'll be called out on your setup sheet, and that way that information can be rolled into notes that go into, see how this is Haas VF1 machine op 1. That details that you put in there could be added as a note for the operator who's going to come back and run your parts in the future. So it's important that you do the documentation well, because the program's only as good as the setup information that someone else would use to set up your part. So ideally you would have instructions that are good enough that you don't have to be here. We also need to reference this for the material we're using. So the material that was ordered is this bar size. So that's what we need to set up Fusion. It's a 1 inch by 1 1/4, and it's cut to 6.6 long, plus 100 thousandths minus 0. So we're going to set up our stock. Our ideal stock size needs to match this configuration here. Okay. So that may be out of your control to decide, depending on the level of control the company you work for has. Okay, so we also want to reference the drawing on how we're setting up our datums. If we look at this, this drawing doesn't have GD&T, but there's still an implied datum here. If you look at where the dimensions radiate from, we have or reference from, you have these length dimensions that are referencing the right side of the part. So we know this flat on the right side is one of our datums. And then we have an overall width, and then we have a dimension coming that defines that it's equally split or centered. So that makes this bottom edge another implied datum, because that's where most of the dimensions are coming from. Our dimensions on the right, this says 2 times for both sides. It's somewhat implied that that is centered over center line. So that width is not that critical, but our center line is dimensioned at half the width of our block. So we want to set this up so that we're referencing our fixture against the same references that the dimensions call our tolerances to try to make the part as close as we can and not be fighting our own fixturing. So when we set this up on the machine, we're actually going to flip this 180 degrees, because we're going to make the back, this corner here will be our origin, and we can put a stop on the left side of the vise, and this edge here will be against the fixed side of the vise. The reason we're doing that is to use this flat edge because it's a good reference, and we don't want to use this radius that we have on this other side as our primary datum, since it's not really called, dimensions are not called to it. Okay, so let's go look at our model. Here's our Fusion model, and I have colored the surfaces in my model that correspond with the drawing datums I just discussed. You don't necessarily have to do that. We're just developing our plan of attack here. So when we fixture our part, we want a fixture contact on both of these red zones, at least for our first operation. Okay, and ideally you want to keep track of those. So here we go. First, we're going to define our stock. Okay, and there's a bunch of different ways to do this. We're doing some 3D machining. I'm going to go ahead and do a little bit longer process where we're actually going to define a body for the stock. Okay, so we're going to create a second body. Before we do that, let's name the body we currently have by expanding bodies, and let's name this the part number 7311. Enter. That way it's clear that that is the part, and if we make other bodies for stock, we're going to label them accordingly. Okay, so first thing we're going to do, we're going to go to sketch, and we're going to sketch we'll go ahead and sketch our stock in the same plane that we used as primary for our primary view. So in this case, it's this, what was the front view. And then we're going to just draw a rectangle around our part. Again, there's a multitude of ways you can approach this. All right, so now let's look at what size was our stock on our Traveler. Okay, the stock size that the planner's designed around was 1 inch bar by 1 1/4 by 6.6 long. So this 1 1/4 is our height of our rectangle, and the 6.6 or 6 inches and 600,000 is going to be our length. So let's measure the length. Okay, 6.6, and our height is 1.25. And that should give us at least a rectangle that's the correct size for our part. Now we need to center around this volume here. I'm going to draw a line from corner to corner on the box. That's an easy way to find center with one entity. And we're going to change that to construction. And then we need to find center on this space here. So if we take another line, and let's just draw this. The smart snap doesn't always work on silhouettes, but we're going to pick the right side of our part, and then we're going to extend that and go past the radius on the left. Click. Then we hit escape, and we should have a horizontal relationship on this part. If that line, if you don't, you need to add it just like that. It gave me an error because I already had it. And then we're going to go to construction line on that feature as well. And we got an association. We want to make an association with the right side and the midpoint of the right edge. Okay, and that'll center our center line, and then hit escape, and we're going to drag the other endpoint. We're going to highlight it, and we're going to make it coincident with the radius of the silhouette. This line that I just created, this horizontal line, is centered on our stock or our model and centered on the volume of it. Now we simply need to create a relationship between the centers of both center lines, and we will have centered our stock evenly around this shape. Okay, so we've now established the boundary, and now I'm going to hit Finish Sketch. At this point, I'm going to look at it in a 3D view. For our first operation, we want to use as much material as possible. We're going to leave as much as possible to hold it in the vise. Our part should be nominally 3/4 of an inch, and we have an inch to work with. So we're going to do an extrude, but we're going to do it in both directions. So we're going to go 2 sides, okay, and in the first direction, if your arrow is pointed up, your arrows might default to a different direction, but in the one direction, we want to go just slightly over 3/4 of an inch because that's how thick our part is. So let's go 0.7 and 5, and we're going to add, let's add 30 thousandths, so we'll make that 0.78. Okay. Now our opposite direction is going to add up to an inch. So if I take my calculator and I take 1 and I minus 0.78 from it, that gives us 220 thousandths. So that's what we're going to go in our opposite direction, 2.2. Okay, and oops, 0.22. Okay, now right now it's defaulting to a cut. It's seeing that there's a body there. It thinks it needs to remove material. That's not what we want to do. We want to create a new body. Okay, and now it should turn gray. This will also make it a separate entity from our model. So we'll have it listed over here on the left as a separate body. We're going to hit OK. And now I can't see my part. So we're going to go over here. We're going to rename this body stock. Okay, and then we're going to right click on the stock, and we're going to pick on opacity control, and we're going to go to 50%, and that will make our stock transparent in the sense that we'll be able to see that our model is still embedded in there. You've created the stock. Our first operation should be pretty similar to other things you've done. We should have 30 thousandths of material to skim off one side, and then we will hold on to the larger portion. And if we use our tallest parallels, we should have plenty of space. However, first operation like this, we're going to bring in a vise. I do want to note that at least this semester, in the spring of 2025, there initially was a different version of this vise attached to the assignment. At the time this video is posted, that has been updated. But if you downloaded a different version of the vise for former projects, you want to make sure that it has 2025 in the name. The reason is I've added configurations for each parallel height that we have in stock. Now for this first operation, we can use the tallest ones, which are the 1 5/8" parallels. We try to use those whenever possible. It gives a minimum grip and maximum amount of material sticking out. So our first vise we're going to import for our first setup is going to be that configuration. Let's hit OK. And we're going to move our vise around so that it's matching the view of how we want to machine our first operation. So I'm going to flip this 180, and flip it down to 90, and then we're going to use joints to put this together. Although I do like to start with the vise position somewhat closer to where it's going to be in orientation, so we'll put it below it, and at least we're starting out somewhat close. Okay. And we're going to do this planning for each setup before we get into CAM, because every time you come in and out of design mode in CAM, you have to regenerate your toolpath. We don't want to do that. Alright, so we're going to hit OK. We're just going to accept that as its display state at the moment. Now we're going to position our material in reference to the fixed jaw of the vise. Okay, so we're going to use a joint for that. And we should be able to achieve this using the default settings. Picking the front corner of the parallel, and we want the origin target to be horizontal when we do this. Okay, so we're going to select right here, and then our second component, which is the model, it's going to be this bottom left corner. And you want your target also to be horizontal. Now we might have to flip the orientation of it, but we're going to pick that. If you get this error, it is because our components are fixed in place and we need to float one of them. So, so we hit OK, and it failed. Okay, so what we need to do is make sure that we right click on this component and we unground this from parent. Okay, and so it will now allow that joint to go into the correct place. So get rid of that error. Your default settings might be different, so you might not have to do that. Okay, so now we've established that this is where the vise is. This is where our part origin is going to be. When we machine this operation, it's going to be at least the back left corner. There's different philosophies on whether to set your origin on the top of the material or the top of the parallel. We'll address that when we get into the CAM of this. All right, and then we have our vise spacing, which it's somewhat semantics unless you're using collision detection, but we're going to set this width here we have here so that the back jaw lines up with this. Now you can achieve it with a joint. It just this in some ways is more flexible. So our measurement is coming from. So we're gonna go to inspect, and we'll measure from our stock to the face of the back jaw, and we currently have a distance of 4.525. We're going to take that number and we're going to adjust the spacing by subtracting that difference, and it should close up to the right distance. Okay, so there's our first operation. Now our second, so we're going to set this up. Our left side is going to be our stock. If we're savvy about how we set up our vise stop, we can put it in a place where we don't have to change our origin. We would hit somewhere down here in the bottom so that when we flip the part, we're not going to have any of these cutters run into it. But for the second side, we can't use the same height parallels. Because of the difference between this fillet and the top edge of the part, which will be machined down to that. So if we look at our drawing, we have what size radius? We have a 200 thousandths radius there. So our parallels, we want to grab this flat here we have in the side view, but we need to leave enough room for the ball cutter to roll around and come past tangency to machine that 200 thousandths. So what we need to do is grab on just as little of this flat here as we can. So we may need to play with the configurations of our parallels to get the right amount. Okay, so for our second instance of the vise, we're going to hide the first instance of the vise. Okay, so now we're going to bring in a second instance of our vise. Drag in our vise. It's going to ask you which configuration parallels do you want to use. With the 1 5/8 parallels, we're only holding on to approximately 80 to 90 thousandths. So we need to hold on. We know we need to hold on to at least 250 thousandths. So we can guess and then we can adjust. But let's start with the 1 1/4 parallels. And we can always adjust later in the configuration. Okay, so we're going to bring in the version with its 1.25" parallels, and we'll make our decision once we have this assembled. Okay, so we want to rotate this so that it's in a rough orientation of how it's going to hold apart. So 180 degrees in one axis and 90 in the other. Let's get it lined up.